All right, here we're going to talk about a second example for the alternating series test. So again, the general formula is -1 to the nth power multiplied by b sub n in our series. Again, this -1 to the nth power can be -1 to the n plus 1th power or -1 to the n minus 1 power. It doesn't really matter as long as it's -1 to the n plus a constant. For example problem today, we're going to have -1 to the n plus 1th power multiplied by n squared, all of it over n plus 1 squared. So in this example, our b sub n is equal to n squared over n plus 1 squared. The alternating series test requirements state that the limit as n approaches infinity of b sub n is equal to 0, and b sub n is decreasing. As long as these two statements are true, then the series will converge. So for step 1, as long as the limit is equal to 0, here's our equation again, this time separated out the -1. So we take the limit as n approaches infinity of b sub n, which in this case is n squared over n plus 1 squared. To figure out if this is equal to 0 or not, we need to be able to input infinity into it. So we multiply it by 1 over n squared over 1 over n squared to multiply every single term by 1 over n squared. So we can have n squared over n squared on the top of our fraction, and then on the bottom we can move the 1 over n squared inside of the parentheses and change it into a 1 over n. Now we have n over n and 1 over n, which gives us 1 plus 1 over n, all of it squared on the bottom. Now the limit as n approaches infinity of this equation is going to be equal to 1 over 1 squared, because the 1 over n inside of the parentheses becomes 0 as you input infinity into it, which is going to give us 1. So since the limit as n approaches infinity of b sub n did not approach 0, but rather approach 1 in this circumstance, the series diverges by the nth term test.